Hello, Math 153. What we're talking about in this lesson is 12.4, the normal distribution. What the normal distribution is, you can see it right here. It's when we have this nice bell curve. This is often sometimes called the Gaussian distribution. And where it comes from is by creating a histogram. Now, this histogram is the sample of 100 men and their height. You can see that most men have a height in the middle, and then the values kind of trickle down from there. You can kind of see that normal distribution here, but it's kind of shaky. As you increase the sample size, meaning if you take that 100 men and turn it into maybe 200 men, 300 men, but as you pull more men, you can see that it becomes less and less shaky, if you will. And as you continue to increase that sample size, it does take on that normal distribution shape to it. This is something that we see a lot in even real life. You can see these stairs here. They even take on that normal distribution curve because most people walk in the center and not so much on the edges. When we do see the normal distribution like this is symmetric, uh, meaning it's the same on both sides. When we have this symmetric, it tells us that the mean, the median, and the mode are all equal to one another, meaning it's going to be the same exact value. If the mean height of a man, we'll say, is, I don't know, 70 inches, that means the median would also be 70 inches and the mode would also be 70 inches. So that's what that shows us. This right here is what we call a skewed distribution because it does not take on that normal distribution shape. We're not going to do very much with this. I just wanted to mention it. So if you see it, you know what it's considered. What we're going to be doing now is we're going to be calculating what we call a z-score. And what a z-score is it's going to be the relationship between a data value and the mean. So it's going to be the relationship between a data value and the mean. And these are measured in standard deviations. The higher the z-score, the further away from the mean that data value will be. And we're going to be using, when we start this off, is we're going to be using this rule. It's called the 68, 95, 99.7 rule. And what this tells us, looking at this normal distribution right here, what these numbers at the bottom represent are standard deviations. 0, as you see here, is the mean. This would mean it's 1 standard deviation above the mean, 2, 3, and so forth. This would be 1 below the mean, 2 below the mean, 3 below the mean. What this rule states is that 68% of all the data values will lie either 1 standard deviation above or below the mean. So 68%, over half. It tells us that 95% of the data values will lie within 2 above or 2 below. And then it tells us that 99.7 of the data values will lie either 3 above or 3 below, is what this is going to tell us. So example 1, finding scores at a specified standard deviation from the mean. Male adult heights in North America are approximately normally distributed with a mean of 70 inches and a standard deviation of 4. Find the height that is 2 standard deviations above the mean. So this problem gives us 2 important pieces of information here. It tells us the mean is going to be 70. It also tells us the standard deviation is going to be 4. We need to figure out what is the height of a man who has the height that's 2 standard deviations above the mean. So the little formula we're going to use here, so we want to calculate a height. We have to take the mean and add it to 2 standard deviations. And we're getting the 2 here because that's what the problem is telling us. And since it says above the mean, that tells us we are adding here. So now we're going to take these values and substitute them into over here. So we have the mean, which is, the mean is 70 plus 2 times 4. So this would be 70 plus 8, which leaves us with a height of 78 inches. That would be the height of the man that has a height 2 standard deviations above the mean. Now looking at the next one. 3 standard deviations below the mean. So again, we have to take the height and we're going to let that be equal to the mean. Now we're doing subtracting 3 times the standard deviation. So we have 70 minus 3 times 4. Again, it's subtraction because it's below. And so we do 70 minus 12, which would leave us with 58 inches. So this would be telling us that the height of 58 inches is 3 standard deviations below the mean. Okay, looking at the next page. So now it tells us to use the rule here. It says using the 68, 95, 99.7 rule, use the distribution of male heights in the figure above, excuse me, to find the percentage of men in North America with heights between 66 inches and 74. So we want to find the percentage of men that have a height between 66 and 74. Well, we can see 66 is here, 74 is here. So we want to find the percentage of men that have all the heights in that range. And by looking at the picture above, you can see that that would be 68% of all men because we see that value right here. That tells us that everything between here and here is 68% of those values. Okay, I'm going to erase this just to make the next one easier. So now we want to find between 70 and 74. Well, 70 is here and 74 is right there. So we want to find what percent has between here and here. Well, this one, if we know the whole thing is 68, then we just want to go with half of that. So if we take 68% and divide it by 2, we are left with, right, 34%. All right, and let's look at the next one. Above 78. So we want to figure out, okay, how many people have a height above 78? So we're looking at from here and everything to the right of it. So this one, there's a couple ways you can look at it. Well, one way we can do it is we can see that if we look on the other way, we see that 95% would be from here to here. With that, that tells us that that would be 95. That means that 5% makes up this and this. So we're only looking at the ones that are above 78. So that would be half of 5% because we know that 95 is from here to here. That means everything on the outside would be 5% of that. So we can take, all right, we can start with that. Oops, let's do this in red to keep it consistent. Let's start with, we know the whole thing is 100%, but we're taking out the 95%. That means we're left with 5% here, but that 5% split between below and above. So we need to divide that in half, which is leaving us with 2.5%. So again, we're just going off the picture alone for those. Okay, now we're going to be getting into the z-score talk. So I said earlier it's the relationship. It tells us how many standard deviation a data item lies above or below the mean. Here's the formula we have to use to figure out a z-score. We take the data item and subtract the mean and divide it by the standard deviation. So example 3 is computing these z-scores. So it says the mean weight of newborn infants is 7 pounds. The standard deviation is 0.8 pounds. The weights of newborn are normally distributed. Find the z-score. So there's two important information things here again. We have the mean is 7 and the standard deviation is 0.8. Those are the two things we have to know. So we want to find the z-score of a baby that weighed 9 pounds. So we have the z-score is equal to, and we want to take the data item, which is 9 in this case, subtract the mean, and divide it by 0.8. You can use your calculator to do all of this. That's going to be the easiest way for it. So 9 minus 7 is 2, divided by 0.8, we get 2.5. So this would have a z-score of 2.5, meaning a baby that weighs 9 pounds is 2.5 standard deviations above the mean. Go ahead and pause the video and try letter B and C. For letter B, you find a z-score of 0. The reason why it's 0 here is because this data value is the mean, meaning it lies exactly there. Letter C is 6 pounds. Right away, you notice that this data value is smaller than the mean, which is why we have a negative. So the data value of 6 pounds is negative 1.25 standard deviations below the mean. Okay, next page. Now, what we're doing here, I'll let you pause the video. You can read through this problem on your own. But what a student takes two tests, arithmetic test and a vocabulary test. And we want to know which test did the student do better on. Now, we don't want to just look to see which test did they score higher on because we don't know where the rest of the students did. We want to think of which one did they do better on, meaning where did they excel in comparison to everyone else that took the class. So we need to look for the z-scores and compare the z-scores. Again, z-scores, data item minus the mean divided by the standard deviation. So what we have to do first is identify what the mean and standard deviation is for each test. So we're going to start with the arithmetic test. They score a 70 on the arithmetic test. The score is normally, the arithmetic test has a mean of 60 and a standard deviation of 20. So let's start with that one first. So we want to find the z-score of this. So the data item is 70, and we're subtracting the mean of 60, and we're dividing it by the standard deviation of 20. Well, 70 minus 60, this one's pretty easy to compute in your head. 10 out of 20 is 0.5. So this tells us that they scored half of a standard deviation above the mean here. So they're very close to the mean on this test. Now, let's look for the vocab test. They score a 66 on the vocab test. The vocab test has a mean of 60 and a standard deviation of 2. So the z-score for this, the data item is 66. We're subtracting the mean of 60 and a standard deviation of 2. So this would be 6 over 2, which is 3. So this means 3 standard deviations above the mean. So which one did they score better on? Right, the vocabulary test. So they did better on vocab test because they had a higher amount of standard deviations above the mean. Okay, the next one. We're going to be going backwards with it now. In these problems, they're going to give us the z-score, give us the mean, and give us the standard deviation, and we need to find what the data value is. This one we're talking about an IQ test. They're normally distributed with a mean of 100. So our mean is 100 with a standard deviation of 16. Now it's telling us it has a z-score of negative 1.5. We are going to be using for these problems the same formula again that we have been using. This time we know the z-score is a negative 1.5, and we're setting it equal to the data item, which we're solving for an IQ score here, so I'm just going to write it in as IQ. Subtract the mean, which is 100, divided by the standard deviation. Easiest way to think of this problem is think of it as a proportion. So if we put a 1 underneath that, we can simply just cross multiply here. So we think, okay, if we do negative 1.5 times 16, negative 1.5 times 16 leaves us with a negative 24. And now we have to multiply 1 by IQ minus 100, so we can just say IQ minus 100. Now the last thing we have to do is add 100 to both sides. So a negative 24 plus 100 leaves us with a 76. So a 76 would be the IQ score here, which you can see a 76 is below the mean. So you just want to double check 76 is below the mean, which is good because the z-score is a negative value. I want you to now go ahead and try letter B here. Okay, and for this one, we should get an IQ score of 132.8. You can look at my math here, see if you did it all correctly. That is all we have for this video on 12.4. Please reach out if you have any questions at all, and good luck on the homework assignment.